Okay, part three, the dreaded part three. Here we go. This is actually going to be a little bit of a long video as well because we have a couple of examples to do. One of the things that we can do with our compound trig identities is to prove other trig identities, and really that's the path that we're headed on, is using these developed ones to be able to prove other trig identities. And how we kind of think of proving a statement like this, if you remember from grade 11, we proved trig identities by splitting the left side and the right side up, and trying to make the left side look like the right side. So the right side is negative sine theta, and there's not a lot we can do with negative sine theta, so we're probably going to be working with the right-hand side. And hopefully you remember that this is actually one of the compound trig identities from yesterday, and this is a fact that we just remembered. But we're going to prove this using our compound trig identity. This one right here. Cos of a plus b is cos cos minus sine sine. Have you got it memorized yet? No, maybe not yet. You could look it up. But what do we have? We have the cos of a times the cos of b, and that just happens to be theta, minus the sine of a times the sine of b. All right, well, what's going on here? This isn't looking much like the right-hand side. Well, what's the cos of pi over 2? And you might know this for a fact, or you might have to think about it. The cos of pi over 2, I could think of as in terms of rotation angles on the unit circle, right? There's the rotation angle of pi over 2, and then these coordinates of where it crosses the unit circle are the cosine and the sine. So this is the cos of pi over 2 and the sine of pi over 2, and so that this thing then is 0. Cos of theta, we don't know what it is, but the sine of pi over 2 is 1. And then that simplifies. 0 minus that is negative sine theta. The left side equals the right side, and the identity is proven. Notice that this little fact here, that cos of pi over 2, you might not have remembered it this way. Maybe you remembered it from your acute angle chart, or perhaps you remembered it from the graph. And as we're learning more and more trig, by the way, there's a number of different ways that we could get the same fact. And they shouldn't be getting in each other's way. They should be helping each other confirm the same fact. So the rotation angles allows us to get the graphs, or the graphs allow us to remember the rotation angles. However you want to think of that, you know, all the trig goodness goes together. So the cos of pi over 2 is 0 because I got that from the graph. Similarly, I can think of the graph of y equals sine x, and it's 1, right? And it goes back down. So this one here is y equals sine x, and then I can see that the sine of pi over 2 is 1, and I get that identity proven. Dandy. Example 3, state exactly. So probably at some point we're going to need our exact angle chart, right? The pi over 6s, the pi over 3s, the pi over 4s, that chart. But we don't have any pi over 12s, so we're a little bit worried about this. We're going to need to use one of the compound angle formulas, right? Well, the idea here is maybe I can find some sort of combination of angles that will give me 11 pi over 6. I need to find an a plus b equals 11 pi, or not pi over 6, 11 pi over 12, I should say, where a and b are known. Somehow I know those ones. Okay, well, what combination of angles a and b might give me 11 pi over 6? Well, notice that if I have, and by the way, this is all kind of rough work at this point. This is all rough work, rough. And I think that I'm going to be using this formula eventually. but I don't know what my A and B is. Hopefully, you don't have to think too hard by seeing the combination of 3 and 4 written as a common denominator will give me 11 pi over 6, right? Because if I'm thinking about putting these fractions together, that's where I can get a common denominator of 12. And 3 and 4 are known angles, right? These are special angles for me, and I can figure that out. Well, notice that pi over 3 and pi over 4, those don't work, because if I were to put pi over 3 and 4 pi, or pi over 4 together, common denominator, that's 7 pi over 12, and not 11 pi over 12. So if I think of that 7 pi over 12, I need 4 more pi over 12. I need another pi over 3, don't I? I need another one here. So I had just one there. If I change that to a 2, and I know this is very guess and checky, and that bothers some of you, but really this is the way we have to do it. To break apart, we're thinking about breaking apart this 11 pi over 12 into 2 pieces that we can handle. Because then I have 8 pi over 12. 8 and 3 are 11. Okay, so there's my A and there's my B. So now I can think of writing my formula. Let's do this nicely. So sine of 11 pi over 12 is the sine. Once I've done my rough work, and the idea is I can find these, the trig ratios of these angles exactly. And so now I'm going to apply my compound trig identity. Yes, I realize that this is a little bit silly. If I really wanted 11 pi over the sine of 11 pi over 12, I could just bash it into a calculator. But a big part of what we do in math is be exact. And so here we're trying to be exact. And so now I see sine of A cos B plus sine B cos A. And now, well, these are all little questions from earlier in the chapter, perfect angle questions. So I need my chart, right? So I'm gonna get my chart and be able to answer these in just a second. Bam! There's my chart. And so why is this so helpful? Because remember, the sine of 2 pi over 3 has the same values as its related acute angle. So I know it's going to be, this value here is going to be this, except for maybe negative. And I'm going to think about that. Again, more rough work. What a question, by the way. What a question this is. Where's 2 pi over 3? Well, 2 pi over 3 is in this quadrant, with pi over 3 as the related acute angle. There's my angle, 2 pi over 3. And so by the cast rule, the sine is positive there. So therefore, the sine of 2 pi over 3 is positive square root of 3 over 2. So this part here is this positive square root of 3 over 2. Same thing over here. The cosine is going to be negative, though, right? The cosine is going to be negative because only the sine is positive. So here I'm going to write down the cos of 2 pi over 3. That's negative 1 over 2. And so this one is negative 1 over 2. The rest I'm going to, well, hang on, I guess I could do this too, because the related acute angles, these are just the related acute angles. I don't even need a diagram. I'm talking about this row right here. These are my values that I put in there. The cos of pi over 2 is 1 over the square root of 2. This is 1 over the square root of 2. Nice. And now I've got an exact value. I'm going to tidy this up a little bit. Like, this is math. We need to tidy things up. Just multiply the fractions. 1, oh, hang on, that's going to be minus 1 there. 1 times minus 1. Hey, I've got common denominators. Isn't that beautiful? That's just screaming to be put together. And by the way, I would be completely fine with this answer. This is the exact answer, sine of 11 pi over 12, is this answer. Now, of course, our textbook, being the wonderful people that they don't like the square roots on the bottom. So they multiply by a convenient form of 1, convenient form of 1, convenient form of 1. They multiply so they can eliminate the square roots on the bottom, right? And we've seen this trick before. 2 times that is square root of 6, square root of 2, 2, and then multiply the roots, that's root 4. This is actually 2. So this is very arguable that that's a simpler form than our original purple one here, but that's the one you'll see in your textbook, okay? Remember to what they call rationalize the denominator. All right, long lesson. But as promised, the homework is a little bit less. There's yesterday's, and you might have bits and pieces of yesterday's, but there's that tan stuff and just a few questions from the homework, and the bigger homework is actually tomorrow. And tomorrow, I think I promise you, can I promise you no new formulas tomorrow? I think I can. I think you've got all the formulas you're going to need for a little while until we start proving our own trig identities. But then tomorrow is bigger on the homework. Less on the lesson, more on the homework, and we'll talk about that another day. That's it for now.